to volume. Now that we've talked constantly about area and surface area and circumference, so now what we're going to do is kind of zip through both of these sections. We're going to go a little quicker and only do a little bit in 9.5 because I really want to concentrate mostly on cylinders with you. So grab your notes for 9.5 where it says solving volume problems. Even though this is in the textbook, today what we're going to do is kind of blast through it quickly. All right. The volume of a prism, or a volume of anything really, is where you are filling an object up, okay? So I like to think of it this way. Can you envision what it looks like when we're pouring water? Let me get that video up right here. Okay, this glass holds some kind of capacity. When we were doing surface area, we were talking about just covering the outside, but now volume is going to be talking about filling something up, like pouring liquid in or something like that, okay? Volume is capacity. So that's going to change what our units look like, and it's going to change how we go about solving these problems, okay? A couple of things I'm going to add here. Your units are cubed or cubic, okay? Sometimes we write that as to the third power because it's like little three-dimensional objects. We do have a formula, and if you look on your handy-dandy formula sheet, it's right at the very bottom, and it just gives you capital B times H, mainly because that formula is generic enough. It can work for any kind of prism or any kind of cylinder. So let's take a look at an example here, and the more we use it, the better we'll get at it. Here is a shipping carton that's shaped like a triangular prism. In fact, think of the two triangles here as the bases. I know it looks like it's laying on this side, but I need you to envision it standing up so that this triangle, which is a base, a little base. Now there's a difference between capital B and little b. The 4 here is little b, and this is the height of the triangle. Capital B stands for the area of whatever shape is your base. This H is the height of the actual prism or the cylinder. When I ask how many cubic inches of space are in the carton, what you're going to do is find the area of the base and multiply it times the height. The base is a triangle, and that formula says 1/2 times the triangle base times the triangle's height, or sometimes people say the triangle's base times height divided by 2. And then the height of this carton is this dimension, which is 15. And then crank this out. 1/2 of 4 is 2. 2 times 3 is 6. 6 times 15 gives us a number of 90. 90 cubic inches is what that container can hold. Now, believe it or not, I want to switch gears and get right into cylinders. So as far as the rest of these shapes and things, I will tell you in your notes that these can be considered extra credit. Here's another triangular one, and then especially this composite shape. All right, but I need you to jump here right now because this is really where we are focused. This is the main, one of the main parts of your geometry standards in 7th grade in Minnesota. How do I find the volume of a cylinder? That is what we're after today. And remember, we defined a cylinder as a 3D object. Its two bases are circles. And it has its lateral side, lateral area. That lateral side is a rectangle. I'm just going to draw a picture. Okay. Again, we have two bases. They're in the shape of a circle. The height measures how tall the cylinder is. So I'm going to put a H there. This is the base. I'm going to call this capital B now instead of little b like we use in the triangle. And again, to find volume, volume is the area of the base times the height. So write it with a capital B, and then right on here, this is the area of the base. We could jump right here, and instead of saying capital B times H, if we're using a cylinder as our object that we are trying to calculate volume, pi r squared is the formula for area of a circle, and then the height looks like that. Okay, so basically we're finding what the area of the base is and then just zip, multiply by the height because that is like filling it up. Okay, again, our units are going to be cubic to that third power. It's a three-dimensional thing. So let's tackle these now. Here's a cylinder. Okay, find the volume. And I'm going to say, let's go to the nearest hundredth because we're using 3.14 for pi. So let's see what happens here. My volume formula says this: area of the base times the height. That means we're going to have to take pi times the radius squared, that's the area of the base, times the height. All right, let's get our handy dandy calculator going. Pi, there's our approximation. The radius is 4 squared times the height. Let's see, that's 16. I guess I can put a 12 in there. All right, if I get pi times that 16, I think that's about the 50 point, is that 50.24? I'm trying to remember. 16 times 3.14. Yep, 50.24. That's the area of the circle. Okay, and then zoop, fill it up. That's the times 12. Your final answer is 602 and 88 hundredths. The label will be cubic inches, or you can say inches to the third power. Let's look at another one. You work ahead, pause the video, and see if you come up with the correct number value. .14. My radius is 8. My height is 15. When I do just the area of the base, you get 296 hundredths. Okay, so that's this part. That's the area of the base times the height of 15, and you get over 3,000. Holy cow. And that's cubic centimeters. Did we match? Cool. Let's keep going. Again, I'm crossing out the tenths because I'd just rather go to the hundredths. All right, on this one, volume is area of the base times the height. Because it's a circle shape for our base, we use pi r squared for the area of the base times the height. 3.14 times the radius squared. Careful! Diameter is 10, which means your radius is 5. That gives us, I believe it was like 78.5. And then we have to multiply by the height, which is 12. That total then gives us a value of 942 cubic inches. All right, here's the last one. I'm going to draw a squiggle line here because we'll do this together in class next time. Find the volume, area of the base times the height. That means pi times radius squared, that's the base, times the height, pi. 15 squared. So the area of the base is a biggie. That gives us 706 and 5/10. The height is 32. I know it looks like it's flat. You need to envision this thing standing upright where this is the 32. Multiply these together and we get a giant value here, 22,608, and we are in cubic centimeters. Awesome work. Use this formula all the time. Okay? With a cylinder, the area of the base is always pi r squared. Look on Schoology and see what your assignment is. As always, good luck and may the force be with you.